Ever since Darwin, biologists have understood the importance of the tree of life metaphor. In PhyloMeth, we will learn how to infer that tree and how to use it to understand biological processes. PhyloMeth is made possible through a career grant from NSF, as well as ongoing support from the University of Tennessee, Knoxville.
So for many years, Treebase was the only place to go to get trees. But a recently funded NSF project called OpenTree of Life has the mission of creating a single synthetic tree for all of life. And to do that, they're pulling information from published trees, which they actually store internally as a database, as well as from existing taxonomy, right? Because there are many, many more species named than there are in published trees. And so they use the taxonomy to give a backbone and then resolve that with published trees as they come out. If you go to OpenTree of Life, you can then go and interface with these trees. Here's their tree view, and here's their part of their phylogeny of all of life. We can zoom in and look at particular clades. So let's do Anolis. And so here we see their subtree for Anolis. And you see there's some resolved branches, right? But also a lot of polytomies, right? That's because not all these have been incorporated into, published trees. This mostly comes from a taxonomy. And so what you can do with OpenTree is download their synthetic tree as a Newick string, that's basically just the tree structure. Or you can also look at the source trees that lead into it. In this case, there's two different sources. One is a paper by Pyron et al., 2013, and the other is existing taxonomy. And so let's go look at the study and load the information from the study. I'm going to take a few minutes. And here we see metadata, so data about the data. In this case, the citation. So you can go read the paper and see if you like this tree. Reference to where you can get to the citation, what year it was, what vocal clade, and so forth. Okay. You can also download the tree itself in different formats. So Newick is the basic tree structure, right? So just the tree itself. Nexus includes the tree and basically Newick format plus additional information. It's probably the most commonly used tree format. NexML, which is similar to Nexus in feel, but it's actually an XML-based format. And Nexon, which is OpenTree's JSON-like format for Nexus files. Let's use the Nexus one, so we'll click on that. And we see here's the tree in Nexus form. And it's just in our web browser where we can't really use it well. So what we can do is just save it. And we can either keep it as this name or drop the extension because it's actually a Nexus file, not a text file. Save. Don't append text. Once that's saved, we can then open it in various text editors. So I can open that, say, in here, and here I can see this Nexus structure. Right, so I start with number sign Nexus, begin, in this case taxa, information about that. So we have 4,000 species, what the names are, then end of that block, and then another block about trees, tree name, tree that is a tree name, and then the tree structure as a Newick string with taxon names and then branch lengths in this case, and then end for that block. And so we can take that tree and then load it into Mesquite or R or Python or Figtree, or a variety of different programs or applications to start using that tree for other science. Okay, and again, making sure to cite both OpenTree of Life and also the source trees for the trees you use. Okay. Now, interacting with the website is handy, but it's even better to be able to do that programmatically, right? And so there's a recent R package called the ROTL, R interface to OpenTree of Life, you can get from CRAN or from GitHub. And so here's instructions on how to use it in GitHub. This is created as a part of our OpenSci, which is a consortium of scientists who produce tremendously useful packages for pulling information from GBIF or NCBI, Treebase, OpenTree of Life, many different sources. And so if you never need to get data into R, look at R OpenSci first. And so here is information about how to get that. And it has things that are called vignettes, which is sort of R speak for user manuals. And so here's a basic vignette that tells you what you can get from OpenTree of Life. So you can get the synthetic tree, so this clumped together super tree, and get parts of that tree if you want. You can get information from the graph of life, so the possibly conflicting tree topologies right, including the source trees. You can get taxonomic name resolution service, right? So taxonomy is always changing. Things keep getting split, things are corrected, sometimes misspellings of names, and this allows you to change all your taxon names to ideally the same taxonomy. Right? So that way if something's split in one study and merged in another study, you can put them together. Okay? You can get the taxonomy itself, and also you can get information about the studies. Okay? And so there's information in this vignette about how to do that. I'm not going to walk through all of it. It's really well written. You can sort of hit the high points. Right? So if you want to resolve names, you can enter a set of names and then run this TNRS match name. It'll give you new names that match. Okay. We can get a subtree for some taxa. So if you say, I want to get a tree for Nolus based on your synthetic tree, you can pull that tree in. Okay. And finally, you can get trees from studies. Right. So if I have, I want to find all my Nolus trees, I can enter, in this case, the mammalian trees. Right. I can find studies that have this property of the focal clade is mammals. Right. We get a bunch of studies, and then we can look at what those studies are, and get information about the metadata for that study. So again, the publication, who wrote it, when it came out, and then you can actually pull those trees into R and use them directly.